Friends, very good morning to everyone. Today's subject of discussion is synthesis of 6 purine. We have seen TROPS purine synthesis, and 6 purine is the purine molecule with SH group at the 6th position. I'll take 6 purine as a drug which belongs to the class of antimetabolites of antineoplastic agents. It also has immunosuppressant property. It interferes with the synthesis of nucleic acid and it finds its use in the treatment of leukemia, a blood cancer. It interferes with the nucleic acid synthesis by inhibiting phosphoribosyl pyrophosphate amidinotransferase enzyme. Today, let us look into the synthesis of mercaptopurine. The purine molecule was a slight modification of drop synthesis. In drop synthesis, we took urea as the starting material. Here also, the urea has been taken and there it was treated with ethyl cyanoacetate. And here it has been replaced with diethyl malonate. The nitrogenous lone pair of electrons and the carbonyl carbon is the positive center. As we know, the unlike poles attract each other. It forms the bond with the carbonyl carbon and ethoxy, the easy leaving group, it loses as ethanol. There is lone pair of electrons on this nitrogen too. It attacks on the other adjacent carbonyl carbon and ethoxy gets kicked off as ethanol. And a cyclization occurs and I'll get a 6-membered ring with 2 nitrogens. When you heat it strongly, it undergo aromatization. The driving force is that aromatic compounds will be more stable. The bond between nitrogen and hydrogen breaks and it forms, those electrons forms bond with the adjacent carbon and once these electrons are taken away from this, H becomes electron deficient, H plus. This has to maintain its tetravalency. Pi electrons moves onto the oxygen, it becomes O minus, and O minus combines with H plus to give OH. Similarly, here also the carbon hydrogen bond breaks, pi electrons moves and attack and combines with H plus, and it also becomes OH. The nitrogen hydrogen bonds are broken and its electrons are utilized to form the bond with the adjacent carbonyl carbon and pi electrons moves onto the oxygen to maintain the tetravalency of that carbon and O minus combines with H plus and I get corresponding pyrimidine ring 2,4,6 trihydroxypyrimidine. Now I have to add nitrogen at the 4th position. The way drops utilized sodium nitrite and HCl. Here also nitrous acid was generated and this was treated with 2,4,6 trihydroxypyrimidine in the presence of this electrophile. The pi electrons moves onto the carbon giving rise to a carbon ion at the 4th position and it attacks on the electron deficient nitrogen and kicks off OH and I'll got corresponding nitroso derivative. This was reduced by TROPS by using ammonium sulfide but here he has used tin and HCl. I got NH2. I have to add a carbon and it has to be bonded with both the nitrogen to give imidazole, right? That's why what it has been here, OH group is there. I'll treat with isocyanate. The carbon is flanked between two electron deficient groups. That's why it renders this carbon electron deficient. It attacks on this and the electrons moves on to the nitrogen and it becomes NH2. I got corresponding this urea derivative of pyrimidine. The lone pair of electrons on the nitrogen attacks on the carbon of this and OH gets kicked off and loses as water molecule and I will get corresponding imidazolone ring constructed over to the pyrimidine ring system. Now I use this molecule which is formed for further reaction. This undergo aromatization. The bond between nitrogen and hydrogen breaks and this electrons forms bond with the adjacent carbon. Pi electrons moves onto the oxygen and O minus it combines with H plus. It gives rise to corresponding hydroxy group. Now I treat with phosphorus oxychloride. All the OH groups gets replaced by chlorine. POCl3 is a chlorinating agent which is used for chlorination of aromatic compounds. I have got trichloro derivative of purine. Now I hydrolyze with 1 mole of sodium hydroxide. OH minus attacks on the carbon. As this is positive center, it is flanked between the nitrogen and halogen, 2 electron withdrawing group. Chlorine, an easy leaving group, gets replaced. And Cl minus combines with Na plus and it loses a sodium chloride. And the Cl in the position has been replaced by OH. Now, I remove these two chlorines by strongly heating with hydrogen iodide and I will get corresponding 6 hydroxy purine. This OH, if I replace by SH, I get 6 Mercapto purine. 6 Mercapto purine can be synthesized by treating the 6 hydroxy purine by phosphorus pentasulfide. It is a sulfonating agent. It gets replaced by SH. It is a very slow reacting agent and that's why this has been replaced by Lavessen's reagent. I'll get corresponding 6 mercaptopurine. Another purine derivative which finds its use as an anti-neoplastic agent is 6-thioguanine. Here there is amino group at the 2 position. This finds its use in the treatment of leukemia and it also belongs to the class of antimetabolite anti-neoplastic agent. Similar to that of 6-mercaptopurine, it also interferes with nucleic acid synthesis by inhibiting phosphoribosyl pyrophosphate amidinotransferase enzyme. Here, we can take the intermediate what we have synthesized for 6-mercaptopurine and treat with ammonia. Ammonia, nitrogen has lone pair of electrons. And here this is the positive center that is flanked between 3 electron withdrawing groups, chlorine, 2 nitrogens. It attacks on the electron deficient center. Chlorine is an easy leaving group. It loses as chloride. It loses as HCl and it gives rise to corresponding amino group attached to the pyrimidine ring system. Now I treat with hydrogen iodide, strongly heating it. It loses Cl and I will get corresponding Chlorine get removed. Now if I treat with phosphorus pentasulfide or Lawesson's reagent, I'll get corresponding guanine. These two drugs are anti-metabolite, anti-neoplastic agent containing purine as the basic ring system. Next class, we can deal with other heterocyclic molecule containing drugs synthesis. Till then, have a nice day. Thank you.